Amazon Elastic Container Service, or ECS, is a managed container orchestration service that helps you to efficiently deploy, manage, and scale containerized applications. In this video, let's explore ECS by deploying a .NET Web API application using Visual Studio and AWS Toolkit. We will touch on some of the core concepts of ECS and understand how it maps onto the AWS console when these applications are deployed. This is a 1000-level foot view of ECS to just get us going. We will explore each of these topics in detail in future videos. This video is sponsored by AWS and is part of my AWS ECS series. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud, and DevOps. Without much delay, let's get into exploring ECS. ECS is to manage and deploy containerized applications. Now, in our specific case, we will be using Docker to containerize these applications. Now, Visual Studio, when we create a new project, enables an option to create a Dockerized image by default. We will be using this for this first video and will not dive into the concepts of Docker, but I will be exploring them in detail in future videos. So for now, even if you don't understand Docker much, you don't have to worry. Now, ECS, like we saw, is a managed orchestrator, which means it allows you to manage multiple applications running in a Docker container. A typical example might be you have a web API or multiple different services that power your one application. Now, in these cases, you have to run multiple applications, and also you will have to run multiple instances of these applications so that you can scale these applications. Now, these are more common when you have a microservices-based architecture or even when you have pulled apart your application and they are into different processes. So in our demo today, we will explore how the web API can be deployed to ECS as a Docker container, run multiple instances of it, put a load balancer in front of it so that it can talk to the instance as required, and access the API through the load balancer. Now, I won't be doing any of these by hand because Visual Studio AWS Toolkit already does majority of this. But we will see what it does and also explore some of the core concepts and how the things are getting mapped. Like I said, in future videos, I will be covering more details of this and show you how to set this up in a build deploy pipeline and also set it up in the ECS console yourself manually. Before we jump off into the code, let's understand a few key concepts that we will come across today. So here, fundamentally, everything starts with a Docker image that contains your application code. Now, this Docker image is going to be published into a container registry. So that's like NuGet for packages. The container registry is the source for these Docker images. Now, you have different Docker container registries like Docker Hub, etc., which are publicly available, but AWS already provides us ECR, which is Elastic Container Registry. So we will be using that to publish our Docker images. So once we have the Docker image published inside a container registry, we can use that inside a task. So a task is nothing but a pointer to one or more containers and also the amount of CPU and memory that it requires to run that task and port mappings, environment variables, etc. Now, if you're familiar with Docker concepts, this is kind of a Docker compose file. So the task definition is only a blueprint of what and how we want our task to look like. Anytime you create an instance of that task definition, we will create a task, which is basically the actual running code. This is where your Docker image is getting transformed into a running container based on the configurations that you have specified. Now, as you can see here, a task definition can have a direct instance as a task, which normally we would use to run one-off tasks. But this might be to run scheduled tasks or one-off things that you want to do. However, most of the time you want to have long-running tasks and long-running applications in your system. So this is where we would bundle this up, a task definition, into a service. So a service is nothing but a task definition with a specified desired count. This is the number of instances of the tasks that you want at any given time. So let's say in our web API example, we need 3 instances of the task running so that we can put a load balancer in front of it and direct traffic to one of these 3 instances. This helps us to scale the API as well. That brings us to the next thing that gets associated with a service, which is the load balancer. So the load balancer balances the traffic to the different instances of these tasks as defined in this desired count on the service. Now, until here, we were conceptually looking at the groupings of the tasks and the associations with the Docker image, etc. But at the end of the day, these things needs to run somewhere. This is where the ECS cluster comes into picture. So the ECS cluster is nothing but a grouping of the physical resources. So this could either be a Fargate instance or it could be an EC2 instance. Now, a Fargate instance is again a managed environment by AWS where you don't have to manage anything yourself. So this is on the serverless side of AWS capabilities, whereas the EC2 instance, you'll have to create and manage them yourself. So you need to specify a AMI, the OS type, etc., and manage the OS and the things running on it yourself. If you're new to EC2, I highly recommend checking out my video linked here to understand more about that. So coming back, these tasks are going to get executed in an ECS cluster, which is nothing but a group of machines or physical resources that you can run your tasks on. Now in this video, we will be using Fargate so that I don't have to manage any of these instances myself. So now that you have a broad idea of the core concepts, which I will be delving more into future videos, let's look at the application deploy and see how this maps into the AWS console. So let's switch over to Visual Studio, where I have an existing application already open. This is a simple ASP.NET Web API application created by the default template in Visual Studio. So if I navigate into the program.cs, you can see that this has the weather forecast application, the map-get endpoint, and it returns some hard-coded data. For this example, we will just continue with this. So if you want to deploy this to ECS, for now I'll be using the AWS Toolkit that comes along as a plugin with Visual Studio. Now, if you don't have AWS Toolkit installed and set up, I highly recommend checking out my video, which is linked here and the descriptions below. Once you have the toolkit installed, if you navigate to your CS project and if you right click on it, you will see the publish to AWS option. You have two other options, which is publish container to AWS, which is legacy, and also to Beanstalk, which is again is legacy. Let's stick with the current version, which is publish to AWS. So let's select that, which prompts us with a few options to deploy with. The first option is to deploy to Amazon ECS using AWS Fargate, which is also the recommended approach in this case. Now, it also gives you other options like using AWS App Runner, Beanstalk, and also just publishing it to the ECR. So for this, let's select the ECS with Fargate option. Now, if you want to edit the settings for this specific configuration, we can edit this in here. So on the right side, there is an edit settings, and it also shows you the default configuration that it has right now. So let's edit the settings to understand some of these settings. So now we have the cluster name, which in this case, it's saying Web Application 1. We can rename this if we want to Hello ECS. We also have the ECS service. So let's also replace that with Hello ECS service. So instead of the Web Application 1, let's use Hello ECS service. Now the container port that is getting exposed on this is the 8080. So we'll leave it as the same. Now in the compute, we have specified the desired task count to be 3. So if you remember, this number was on the services and it had the desired task count. This is the number of tasks that you want to be creating. So in this case, this is going to create 3 instances of our API application, put a load balancer in front of it, and talk to one of those for any request. Now this has a bunch of other information on the task CPU, the memory, etc., which you will need to adjust based on your application size. Now this again determines the Fargate instance that you will be getting when each of these tasks is getting running on a physical server. Now, since we have 3 instances, we need a load balancer. So this creates a new load balancer and it sets up some of the default configurations required. Now, one of the things that we need to note here is that this requires a health check path. Now, this is simply looking at the /, which the .NET default API doesn't have anything listening to, which means if this is going to hit that endpoint, it is going to return an error and it will think that the instance is unhealthy. So to fix that, let's make sure to add a health check endpoint. So let's switch over to our program.cs. Now, to add health checks, let's simply use the built-in health check provider. So let's specify builder.services.add health checks. Now, if you want me to do a specific video on health checks, let me know in the comments below and I will make one for you. Let's also make sure to enable these health checks on an endpoint. So let's specify the app.use health checks, and let's specify the route on which we need this to be used. So in this case, let's simply specify health as the endpoint. So this is going to enable health check on this endpoint. So let's copy this path. Let's make sure to navigate back to our configuration and use that endpoint for our health check path. So now the AWS service is going to poll this specific path to check if this app is healthy or not. If it doesn't return a successful code, it will create a new instance because it thinks this one is faulty. This has other configurations around the health check based on the number of requests that it needs to make, the interval in which it has to poll to check if it's healthy, etc. We also have the auto scaling information, which right now is not enabled. So let's leave it at that way. Now, since this requires permissions on the AWS, it is going to create a new IAM role and manage that through the new IAM role. If you have existing roles set up, you can use that as well. Now, it's going to also reuse the default virtual private cloud, which we will leave it the same way. Now, since I don't need any specific environment variables, I'm going to leave that as empty. So the only thing that I have changed in here was adding the health checkpoint so that ECS knows the right path to poll for health check. So once we have this configured, let's click publish, which is going to publish this to ECS. So this is going to create resources which might cost you money. So if you're looking to do this, you might be incurring some charge based on how many of these components you are creating. Now, if you don't have an AWS account, I highly recommend getting a free tier account. The link will be in the description below, which will give you enough credits to play around with some of these things. So let's click yes, and let's continue to the deploy. Now, this is going to first build up the Docker image, which is already part of the solution. So when I created the new ASP template, it automatically had the Docker file, which sets up the Docker image for us. So I didn't have to write any of this, and Visual Studio automatically generated this for me. Now, if I navigate back to the deploy, you can see it's built the Docker image, and now it's publishing it to the ECR repository. So this is the centralized place where we can pull these images. So anytime you make a change to your application, you will be building a new image, which will have a new version tag and get published to the AWS ECR. This is very similar to us publishing NuGet packages or even publishing different versions of our application. Now, with the image pushed to ECR, it's configuring the Cloud Development Kit, which it will be using to create the resources in AWS. Now, once it's done, it's going to deploy the AWS CDK project. Now, this is all part of the AWS Toolkit and the option that we chose to use AWS ECS along with Fargate. The only input from our application code was the Docker file, which it used to build the Docker image. So once this is all set up, you will see that it has started deploying the application into our AWS console. Now, if I switch over to my AWS console and let's navigate into the CloudFormation section, which you can also navigate to by searching CloudFormation here, but let's just navigate through this. And you can see here, there is a web application 1 and the create is in progress. So let's navigate into that and you can see the details of the deployment. So you can see there's resources getting created. So if we expand this, we can see the different components that is getting created. So the ECS cluster, the IAM role, the task definition, web security groups, Fargate service, the load balancer, etc. So you can see the creation is in progress while Visual Studio is managing this from our IDE. So you can see there is a loading sign which is waiting for this particular task to complete. So Visual Studio is right now polling this stack information and waiting for it to complete. So since the create is in progress, this is also showing the loading sign. So let's wait for this to finish and let's explore the resources. With the magic of video editing, I have fast forwarded in time and here we have this whole deploy complete. So you can see the create is complete, and if we navigate back to the stack, this creation is complete. So if we navigate into that again, you can see the resources that it's created. So if we expand the recipe, we can see the ECS cluster, the Fargate service, load balancer, and all the other things that our CDK deploy script created. Now, if you want to see the actual CloudFormation template, you can also navigate into the template section, and here you can see the CloudFormation template. So if we navigate back into Visual Studio, we can see that is also completed with the green check mark. So let's navigate into this and understand a bit more. For that, let's navigate back to the home page and let's go into Elastic Container Service. We can also look at the Elastic Container Registry to see our image. So let's open that in a new tab. and let's navigate into container service as well. Here we have the Hello ECS cluster, which has 3 running tasks. So let's navigate into that, and you can see the ECS cluster information. So this is the cluster which is running our ECS service. So you can see here there is one service running, which is the Hello ECS service. Now, if we come back to our UI, you can see the service has the desired count and it also has the task definition. Now, the service is what is getting executed in a cluster. So what we just now saw is the cluster, which has a service associated. So if you navigate back, you can see there's one service inside here. You can also go to the tasks that's running under that, and here you can see there's 3 tasks. So if we navigate further into the service, so let's go to the Hello ECS service, we can see this has the health check and the other information on this. So you can also see there's 3 tasks that is desired. So that is the desired count that we need on the service, which controls the number of tasks that's getting created for that task definition. So let's navigate back. Here you can also see that our service has the load balancer information attached with it, and it has automatically created a load balancer. Now, if we further navigate into the tasks, you can see that there is 3 of these tasks right now running, and there is a task definition associated with this. Now, in this case, all the task definition is pointing to the same one. So let's open that in a new tab where we can see the task definition. So this task definition defines the image to use, the memory, etc. We saw that in our diagram earlier. So if we go into the task definition, you can see that there is an image URL which is specified in the containers. So you can see the app container definition. So let's navigate into the app container definition, and you can find the reference to this specific image. So in this case, it's looking at the ECR repository and it's looking for the web application 1 with this specific version tag. You can also see that the task definition specifies the memory and the CPU settings, port mappings, environment variables, etc. So let's click Done on this. Now, if I navigate into the Amazon ECR, which we opened earlier, you can see that there is a web application 1 image that was just created. So if we navigate into that, you can see the different versions of this. So you can find the image version tag in this, which starts with 63 and ends with 35. So this is the image that is getting referenced inside our containers here. So if we open this again, you can see this is 63 and ends with 35. So it's referring that image inside this task definition file, which is getting run on the services and on the cluster. So let's navigate back to the root of all this, and let's navigate again to our cluster. So if you further navigate into the cluster, we'll get the load balancer. So if I navigate to this load balancer, we can get the URL that this app is now hosted on. So if you go into this specific load balancer details, you can see the DNS mapping for this load balancer. So let's copy that DNS record, which is the public available address for this specific load balancer that is automatically mapped. So let's open a new tab. Let's go to this endpoint, and let's go to the /health endpoint, which is the health endpoint that we created. So you can see this right now returns healthy, but this is returning from one of the 3 instances that is running on this specific cluster. So if I go into the ECR again, so let's understand that a bit better. We have 3 tasks, and the load balancer is routing the traffic to one of the 3 tasks in here. So these 3 tasks is actually running on a physical machine. So if you navigate into that, you can see the private IP and the public IP of this specific Fargate instance that it's running on. So you can see the launch type here is specified as Fargate. Now, if I further navigate into the load balancer for this service, we can see the IP mapping that's specified on that load balancer. So if I go to the load balancer, let's look at the targets, and you can see the 3 different IP address and the ports that it is targeting this load balancer to. So these are the 3 Fargate instances that's running our application. Let's go back to our public endpoint, and let's hit the weather forecast endpoint, which is going to be returning us the data. So you can see this is going to return us the JSON data from one of these instances. So if I refresh this, it's going to return a random different data. Now this can be coming from one of the instances that is running our application. So we have successfully deployed our .NET API application into ECS, running on a cluster using Fargate, and it has 3 instances of this API running. So even if one of the instance crashes, there will be 2 of the others that's still serving traffic. and ECS will automatically bring up a new instance. Now, earlier when we deployed the application, I told you that this is a default ASP.NET API application, but I had added one new endpoint in here, which is called /terminate. Now, all this does is take in a request, it returns a result OK with terminating, but it creates a task in the background to terminate that current instance. This is simply to simulate a bug inside the application or an issue that could happen, let's say a memory exception, which would cause the application to crash. Now in this case, all I'm doing is specifying environment.exit, which will shut down this current application instance. So when ECS next polls this instance for the health check, it will not return anything and it will consider it as unhealthy, which means it will automatically create a new instance by deleting the old one. Let's see this in action. So let's navigate back to our browser tab. Now instead of hitting the weather forecast, let's hit the terminate endpoint. So let's remove that and let's hit the terminate endpoint. Now this is returning back a terminating, which is successful. So if I navigate back into our service task and refresh this, you can see in 30 seconds, one of these is getting removed. This is because that instance has been terminated, and now ECS will detect this and automatically create a new instance. So this happens based on the configuration that we specified inside our ECS cluster. So if we navigate back into Visual Studio, right-click and see Publish to AWS again, let's edit this settings. Let's say start over so that we get the settings again. Let's edit this. Wherever we specified the health endpoint, there was also other information that's associated with this to see what is the health check interval, in this case 30 seconds, the threshold count, the unhealthy threshold count, etc. So this is what controls how fast and how soon a ECS cluster will know that one of the instances is unhealthy and create a new one. So if I navigate back and refresh this again, you can see a new instance is up and running with our application code in it. Now, if I go ahead and run this 3 times, which means all 3 instances will be terminated, there will be nothing to return us back data. So right now, if I switch over to the weather forecast, this is still returning data. Now, if I run this 2 times, let's refresh this once. So it has terminated 1 instance and it has also terminated 2 instances, which means I will still get back some data because it is getting the traffic from that one instance. However, it can randomly hit one of the terminating instance and return back bad data. So if I terminate again and let's hit this endpoint again, you can see if you keep refreshing, one of the times it can return a bad gateway request because it couldn't find the instance that it was running on. So you can see there is a gateway timeout error because it has hit one of the faulty instances. So if you navigate back into the service tasks and refresh this, you can see we have terminated all the instances and right now it is in the provisioning and pending state. So this is going to take some time to come back online. So one of them is running, which means if I come back and refresh this again, I should be getting data sometime soon. So you can see the API is back up and running again. So now once all the services are running, we should be reliably getting this API results back again. So you can see this time we are not getting any errors. So based on the desired count that we have set up on the service definition, you can see that ECS always manages that many instances will be running for our specific service. So in this case, we specified 3, which is why it is making sure that 3 of these are running at any time. I hope this gives you a high-level picture of ECS and the different concepts that's involved with it. We will be exploring more topics in the future, and if you want any specific ones to be explored, let me know in the comments below. If you like this video, please don't forget to like and subscribe. Thank you and see you soon in the next video. Before you go, if you want to make sure you're not incurring money on your AWS account, make sure to delete all those resources that we created. So it's easy enough to do. So if you navigate back into the cloud stack or the stack sets where we saw in the cloud formation getting created. So if you go to the stacks, you can find the stack that the CDK created. So in this case, that's web application 1. So let's click that and say delete. So this will take some time to delete, but that will happen in the background.